Okay, this is the solutions for test 1 fractions. Question 1, write an example in the space provided for each type of number and fraction. Whole number, we'll use 1. Proper fraction, top is smaller than the bottom. Improper fraction, top is larger than the bottom. Mixed number, a whole number, and a usually proper fraction. Number 2, add and subtract the following fractions. I'm going to choose 64 to be my base, so I'm going to convert everything to being over 64. So 27 over 16, I multiply the top and the bottom by 4. 19 over 32, multiply the top and bottom by 2. I forgot to write 64 here. 5 over 8, multiply everything by 8. 41 over 64 is fine. 6 and 128 can both be divided by 2 to reduce this. And whole number 3 times 64 will get us this. Add this all together and you should get 5 1/4 after reducing. Number 3, multiply divide the following fractions. Okay, so first I'm going to convert the mixed numbers and the whole number into improper fractions, just because I think it's easier this way. Great. Now let's go ahead and actually do the multiplication. So 5 times 7 is 35 over 16. Divided by 5 over 4 times 4 over 1. Divided by 7 over 2. It should be 7. There we go. Okay, great. So this becomes 35 over 16 times 4 over 5. Great. So this becomes 140 over 80 times 4 over 1 divided by 7 over 2. Moving over here so I have more room. This becomes 560 over 80. Yep, okay, 560 over 80. I was thinking ahead a bit and I thought I screwed it up, but I think we're good for now. There we go. So lastly, again, I have division, so I need to change the sign. There we go, change the sign and flip the fraction. Great. Let's go ahead and do this multiplication. So 1120 over 560 gives us 2. And just for sanity's sake, yes, okay, 80 times 7 is 560. I'm not that crazy yet. There we go. So that was page 1. Page 2, add, subtract, multiply, and divide the following. Okay, let's go. Here we got -9 divided by 4 times 8 over 3. Excuse me. I'm flipping the fraction and changing the sign first here. Yeah, 3 over 2. There we go. Okay, so let's go ahead and do some multiplication here. Here I have -9 times 8 is going to give me -72 over 4 times 3, which is 12, times 1/2, plus, we're going to leave this as 3. We're going to leave this as 1 1/2, actually, for now. Makes sense why in a bit. Negative 72 over 12. I'm going to go ahead and reduce that. They're both even, but actually they're both divisible by 6. And this turns out to be exactly -6. And writing out the rest. Great. -6 times 1/2. This is just going to give you a -3 plus 3 plus 1 1/2. Great. So I have a -3 and a +3. They cancel out to leave me with just 1 1/2. So that was number 4. Number 5, add, subtract, multiply, and divide the following. The 1/2 fraction has no units on purpose. Great. So first let's take note of units. I got feet, 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 and then inches at the end. Right off the bat, this is telling me that it's probably easiest to convert the inches into feet and just deal with everything in feet, which is a totally valid, completely fine way to solve the problem. However, I'm going to deal with all the feet first because I see that I'm dividing and then multiplying all the feet and then adding them together first before I deal with the inches. So by the time I get to the inches, I'm only going to have one number with feet and one number with inches. So I can make my choice later. And it's actually the same amount of work to go either way. If you don't see it that way, that's fine. You can convert your units first and still get the same answer. I'm just trying to think of how to do this in the easiest way. So with that, let's just get started. -9 over 4 feet times 8 over 3. And this is 1 over feet as the units. Let me make a bit more space and just say feet. Great. So when you flip the fraction, you also flip the unit. That is why I have 1 over feet there. Great. And feet and 1 over feet cancel out. And I still get my -72 over 12 times 1/2 plus 4 feet plus 18 and 1/2 inches. Great. We already know that this is going to be -6 from earlier. And we know that the -6 times 1/2 gives us -3 plus 4 feet plus 18 and 1/2 inches. So -3 plus 4, that's just going to be 1 foot plus 18 and 1/2 inches. Now at this point you can go either way. However, I think it is going to be easiest to convert straight to inches from here. So this is going to be 12 inches plus 18 and 1/2 inches to give us 30 and 1/2 inches as our final answer. So it's page 3 here, questions 4 and 5. Question 6. If 5 1/16 inch steel plate is used to construct a pipe, what will be the outside diameter of the pipe if the inside diameter is 12 5/8, as shown in the figure? So here we need to add the thickness of the pipe on the left, which is 5/16, plus the inside diameter, plus the thickness of the outside pipe. I don't know why I wrote 18 there. That's 16. Great. Add all this together using a common denominator or just punching it all in your calculator. You get 13 1/4 inch. Number 7. From the attachment bracket shown in figure 19, calculate distance A. So if the full distance is 5 11/16 of an inch, that means that 5 11/16 has to be equal to 1 23/64 plus 1 7/8 plus 63/64 plus A. Or if we go ahead and rearrange this, this is that A is 5 11/16. Let me zoom in a bit. There we go. That's better. So A is going to be equal to 5 11/16 minus the rest of these numbers. So minus 1 23/64 minus 1 7/8 minus 63/64. Again, finding a common denominator, probably 64 in this case, and adding them all, or subtracting them all, or just punching this straight into your calculator, you should get 1 15/32 of an inch for A. Please don't forget your units on these questions. All right, number 8. On an order for link pins, it is specified that 7 5/8 of stock is required for each pin as shown in figure 18. Using an abrasive cut-off saw and allowing 1/8 of an inch for each cut, how much material is left over from a 242-inch piece of stock if 30 pins are cut off? So first off, let's find out how much material in total, including the waste, is needed for a single pin. So that is 7 5/8 plus 1/8. That's just going to give us 7 6/8 or 7 3/4 of an inch per pin. So that's the material needed for one pin. And let's multiply that by 30 because I'm going to have 30 pins. So okay, just punching this in my calculator quick. Okay, great. So this gives me 232 1/2 inches for all of the actual pins and the waste. That is the total length. So now I'm going to take, I want to find what's left over, so I'm going to take the total length of what I have, and I'm going to subtract the total length of what I need, and this leaves me with 9 1/2 inches of leftover material. So that was question 8. Again, please don't forget units. Question 9. A rough casting weighs 8 5/16 pounds. After it's been cleaned up, it weighs in at 7 5/8 pounds. How much material was removed? This one, we just go ahead and do the subtraction. And this leaves us with 11/16 of a pound. Again, please don't forget units. If you don't remember the abbreviation for something, just literally write the word. Pounds, inches, feet, doesn't matter. But for pounds, it is LB or LBS. For the bonus, simplify this fraction. Basically, what I'm going to look at this as is one fraction being divided by another fraction. Instead of A divided by B divided by C divided by D, I'm seeing this as one fraction divided by another. This is because that center line is larger than the other ones. So this is telling me I have one fraction divided by another fraction, not just one number divided by another, divided by another, divided by another, divided by another. So in this case, I'm going to have A over B divided by C over D. And using our switching division to multiplication trick, I get AD over BC as the final answer here for the bonus question. So that was everything. The final page was just blank space in case you needed it. If you have any questions, please email me, ask me in class. Otherwise, overall the test was done very well, so congratulations. Again, if you have questions, just ask.